Graphics Core Next is the codename for a family of graphics processing unit microarchitectures as well as the implemented instruction set developed by AMD and launched in 2011 is the successor to TeraScale, which was introduced with the Radeon HD 2000 series. GCN is used in 28 nanometers graphics chips in the HD 7700 to 7900, HD 8000, RX 240 to 290, and RX 300 series of AMD graphics cards. GCN is also used in the AMD Accelerated Processing Units codenamed Temash, Kabini, Kaveri, Carrizo, Beema, and Mullins, as well as in Liverpool and Durango. GCN is a RISC-SIMD architecture contrasting the VLIW-SIMD architecture of TeraScale. GCN requires considerably more transistors than TeraScale, but offers advantages for GPU computation. It makes the compiler simpler and should also lead to better utilization. GCN implements Hyper-Z. An LLVM code generator is available for Graphics Core Next. It is used for example by Mesa 3D. Overall, as of September 2015, the family of microarchitectures implementing the identically called instruction set Graphics Core Next has seen 3 iterations. The differences in the instruction set are rather minimal, and microarchitectures also do not differentiate too much from one another. Graphics Command Processor The graphics command processor is functional unit of the GCN microarchitecture. Among other tasks, it is responsible for asynchronous shaders. The short video AMD asynchronous shaders visualizes the differences between multi-thread, preemption, and asynchronous shaders, HTTP, AMD DevPension NETDN ACDN Comedia 10/asynchronous shaders white paper final PDF, HTTP, www and AMTechCon 9124/AMD dives deep on asynchronous shading. Asynchronous compute engine The asynchronous compute engine is a distinct functional block serving computing purposes. Its purpose is similar to that of the graphics command processor. ASIC blocks The biggest differences lie in the additional ASIC blocks available on the concrete chips. Such ASIC blocks have nothing to do with either the GCN microarchitecture nor with the GCN instruction set. These are simply ASIC blocks that are present on all or most chips implementing a certain iteration of GCN. As this article is actually supposed to document the GCN instruction set and microarchitectures, it is a bit confusing to find information on the ASIC blocks here as well. Unified Virtual Memory In a preview in 2011, AnandTech wrote about the unified virtual memory, supported by Graphics Core Next. Heterogeneous system architecture Some of the specific HSA features implemented in the hardware need support from the operating system's kernel and/or from specific device drivers. For example, in July 2014 AMD published a set of 83 patches to be merged into Linux kernel mainline 3.17 for supporting their Graphics Core Next-based Radeon graphics cards. The special driver titled HSA kernel driver resides in the directory GPU SAR while the DRM graphics device drivers reside in GPU DRM and augments the already existent DRM driver for Radeon cards. This very first implementation focuses on a single Kaveri APU or on a Berlin APU and works alongside the existing Radeon kernel graphics driver. Iterations Graphics Core Next GCN 1.0 Documentation, HTTP Developer and Comedia 12/AMD Southern Islands Instruction Set Architecture PDF, support for 64-bit addressing with unified address space for CPU and GPU support for PCIe 3.0, GPU sends interrupt requests to CPU on various events. Support for partially resident textures, which enable virtual memory support through DirectX and OpenGL extensions. AMD PowerTune support, which dynamically adjusts performance to stay within a specific TDP, support for Mantle. The GCN 1.0 microarchitecture combines 64 shader processors with 4 TMUs and 1 ROP to a compute unit. There are asynchronous compute engines controlling computation and dispatching. Zero core power. Zero-core power is a long-idle power-saving technology. AMD Zero-core power technology supplements AMD Power Tune. Chips, discrete GPUs, Åland, Cape Verde, Pitcairn, Tahiti. Equals GCN second generation GCN 1.1 equals. Documentation, HTTP developer and Comedia 07/AMD C Islands Instruction Set Architecture PDF. GCN 1.1 was introduced with Radeon HD 7790 and is also found in Radeon HD 8770, R7 260/260X, R9 290/290X, R9 295X2, as well as steamroller-based desktop Kaveri APUs and mobile Kaveri APUs and in the Puma-based Beema and Mullins APUs. It has multiple advantages over the original GCN, including AMD True Audio and a revised version of AMD's PowerTune technology. The A10-7850K Kaveri contains 8 CUs and 8 asynchronous compute engines for independent scheduling and work item dispatching. At AMD Developer Summit in November 2013, Michael Mantor presented the Radeon R9 290X. Chips, discrete GPUs, Bonaire, Hawaii, integrated into APUs, Temash, Kabini, Liverpool, Durango, Kaveri, Godavari, Mullins, Beema. Equals GCN third generation GCN 1.2 equals, GCN 1.2 was introduced with the Radeon R9 285 and R9 M295X, which have the Tonga GPU. It features improved tessellation performance, lossless delta color compression in order to reduce memory bandwidth usage, an updated and more efficient instruction set, a new high-quality scaler for video, and a new multimedia engine. Delta color compression is supported in Mesa. Documentation, http and dev-pengen netdnacdn Comedia 07/AMD GCN3 Instruction Set Architecture PDF. Chips, discrete GPUs, Tonga PRO and Tonga XT, from the Volcanic Islands family comes with ASIC block UVD 5.0, Fiji, from the Pirate Islands family comes with ASIC block UVD 6.0, integrated into APUs, Carrizo. Equals GCN 4th generation GCN 1.3/2.0 equals, GPUs of the Arctic Islands family will be introduced in 2016 with AMD Radeon RX 400 series branded graphics cards. Any Arctic Islands chip will be produced in 14 nanometers process. Chips, discrete GPUs, Ellesmere Island, Baffin Island, Greenland, integrated into APUs, TBA. See also, List of AMD graphics processing units. References